Hello, my name's Jolene Rhodes, and today we're going to talk about inverse functions. Now, before we can talk about what an inverse function is, let's recall the definition of a function. So, by definition, a function is a relationship in which each input has exactly one output value. Now today we're going to talk about inverse functions. That means they do need to be functions. So they still need to meet the same definition of what a function is as well as being an inverse. Now an inverse, the best way to think about an inverse is an inverse will undo whatever the function did. So it's kind of like watching a movie in reverse. If you watch the movie forward and then watch the movie in reverse, what you end up with is exactly, when you're all done, exactly where you started. So you progressed one direction, you progressed back in the opposite direction, and ended up exactly where you started. And an inverse function will do the same thing to a function. So therefore, what I want to do is just kind of start with an example in words. So if we look at an example, and my example is not mathematical at all. So for example, I walk to my car, I open the door, I get in the car, and I put the key in the ignition. Now you can see where I'm sitting right now. Perhaps maybe I ought to shut the door. So now I've shut the door of the car, and I'm sitting in my car, and this is my function. So this is the steps to my function. What I would like to do for the inverse is to actually kind of like watch that in reverse. So what would we do to undo the steps that we just did? Now keep in mind we had 5 steps to start with, so we're probably going to have 5 steps to undo those same things. Now, can I like leave from my car? No. What I'm going to do is I need to actually undo my items in the reverse order that I did them in the first place. So the last thing that I did was I shut the door. So the first thing that I'm going to want to do for my inverse is I'm going to want to open the door. Then, what am I going to do? I'm going to remove the key from the ignition. Thirdly, again, what are we doing? We're going backwards. So I got in the car, so I want to get out of the car. Fourth, I'm going to shut the door of the car. And then the fifth thing is I walked to my car, so I am going to actually walk away from the car. Now, if you missed all of this, then when I am done, it should look like I haven't moved. So I actually did all of the steps to the function, then all of the steps to the inverse function, and ended up back where I started. So just keep that in mind, and we're going to use that to think about inverse functions when we get and actually use some numbers and algebra equations. Okay, continuing on this thought, if we take a number, any number, so, pick your favorite one. I'm going to pick the number 5, and I plug it into a function. Okay, so say my function is y is equal to 2x plus 1. So what I'm going to do is I'm going to put the number 5 into that. And if I put the number 5 into that, then this is our input of 5. We're going to use our function. We're going to put it into our function. So we're going to take 2 times 5 plus 1. And what we end up with is what? We end up with an output of 11. So for my original function, what I'm going to do is I'm going to take my input of 5 and I'm going to get an output of 11. The idea with an inverse then is what we need is to be able to, we're going to take that number we got as an output. So we're going to take the 11 and it now becomes the input of our inverse function. We're going to do some kind of steps here and what we should end up with is an output. But remember, the idea is that we should end up back where we started. And we started with this input of 5, which means that our output of our inverse should be the same as that input value of 5. So when I put an input of 5 into my function, output of 11, the inverse, we should get an input of 11 and an output of 5. Now the steps that are in here, we're going to worry about filling in later, but for right now, this actually gives us a perfect way in order to be able to find the inverse of a table of values. So for example, if I had a table of values, and this is my function, say y equal to f of x, and so I have x values, and I have y values. Now I am just going to make up a table of values here. I'm not actually going to have a rule, so we're not going to worry about that. My table of values is, say, the 0.25, point -1, 0, -3, and 4, 7. So now this is my original function. The idea here then is if I have the inverse of that function f of x, then remember the inputs of my inverse should be the outputs of the original and vice versa. So when we look at this, the 0.25 has an input of 2 and an output of 5. So in the inverse, we're going to put the 5 in and we should get a 2 back out. And the same for the other points. So the 0.16 in the inverse becomes the 0.6, -1. The 0.0, -3 becomes the 0.3, 0. And the 0.47 becomes the 0.74. So it's very easy to find the inverse of a table of values. All we're simply going to do is interchange the input and the output values, which basically is the same as also interchanging the domains and the ranges. The domain of your function becomes the range of your inverse, and the range of your function becomes the domain of your inverse function. Okay, so in order to find a inverse function of a table, all we're going to simply do is interchange the input and the output values. Let's continue. Okay, before we go any further, we do need to talk about notation. The notation for an inverse function is f with a -1 up there, f, and that represents f inverse of x. I know it looks a lot like an exponent. It is not. It is simply a symbol that represents our inverse function of f. Okay, now moving on, what I'd like to do is to find the inverse of a function. So for example, if we have f of x equal to my function I had earlier, which was 2x plus 1. Now what we know is in order to use this function, we're going to take a number x, we're going to first multiply it by 2, and then secondly, we're going to add 1 to that number. So for example, if I wanted to find f of 3, what I would do is what? Put the 3 into my function, but in order to evaluate it, the first step is to take 2 times 3, which is get 6, add 1, and we will get an output of 7. So we have an input of 3 and an output of 7. Now that means for our inverse function, we want to do what? We want to have an input of 7. So we want an input of 7, and what we want is an output of 3. Now if you think about this, what do we have to do? We actually have to just undo the steps we did in the reverse order. So the last thing we did was we added 1. So in order to go backwards, the first thing we would do in the inverse is we would subtract 1. And so then we would take 7 minus 1, we would get back to our 6. The second thing we would do then is we first multiplied by 2. So how do we undo multiplication? What we would actually do is divide. So what I want to do then is I would divide by 2. And if I divide by 2, 6 divided by 2 gets me back to 3, which is the value that I started with over here. So my input of my function was 3, my output of my inverse is 3. Now, if I did this with just those numbers, but let's think about this in general. What if I wanted to actually write the inverse? What we actually have right here are the steps to what we would do for our inverse function. So if I wanted to look at that, my inverse function would be to what? It would be to take my number. The first thing I want to do is subtract 1. And then what I want to do is take that result right there, and then I want to divide by 2. Or, if you don't like that notation, I would take my number, subtract 1, and then take all of that and divide by 2. Now, if you actually look at this and we try it with anything, this is actually the inverse. And you can find it this way by actually undoing each of the arithmetic steps. We know what the inverse operations are of our arithmetic steps, and therefore we can actually write an inverse this way. I am going to show you a different way, which some people prefer, but I do want to just prove to you that this inverse actually does work for other numbers besides the one that I gave you. So for example, if we take any other number, pick a number, say -5, and we put it in our original function, we would get 2 times -5 plus 1. Which gives us an answer of -9. If we take the inverse function of -9, we would get -9 minus 1 divided by 2, which is -10 divided by 2, which is -5. And again, notice that this one has the point -5, -9. That's on our original function, and our inverse has the point -9, -5. So they are certainly inverses. Okay, now seems a good time for the official definition of an inverse function. So the definition of an inverse function, what we're going to do is we're going to suppose the inverse of f is a function. Then f inverse of y is equal to x if and only if f of x is equal to y. Now if you look at that definition, that actually says what we've been saying. It basically, again, notice the input of the function is x, the output of the inverse is x, and the output of our function is y, the input of our inverse is y. So all we did was interchange the inputs and the outputs, or the domains and the ranges. Now this gives us a way to actually find an inverse function of a function that's given to us in symbols. So for example, if we go back to our previous example, which if you recall was f of x equal to 2x plus 1, what this says is that, now remember, if we have f of x equal to 2x plus 1, that is actually the same as y equal to 2x plus 1 in slightly different notation, but it is the same. And if we want to find the inverse, then what we really have by the definition is it says that what? The x values become the y values, and the y values become the x values. So if we want to find the inverse, that's all we're going to do, is we're going to actually interchange our variables. So we're going to interchange the variables. We will get x then equal to 2y plus 1. Don't quit there. Our last thought is we do actually have to solve this for y. Now, in order to solve this for y, the first thing we're going to do is we're going to subtract a 1 from both sides. So we'll get x minus 1 equal to 2y. The first thing we're doing is subtracting a 1. And then the last thing in order to solve for y is we would do what? So first thing, subtract 1. And the next thing we would have to do in order to solve for y is we're going to divide both sides by 2. So the last step here is we're going to divide by 2. And we will get y is equal to x minus 1 divided by 2. And that is our inverse function. Now, what I want you to notice is, notice these steps that I wrote right here. They are exactly the same steps that we had when we talked about how to find the inverse up there. And that's why that works. So you can either write down the steps and write then their inverses, or you can interchange the variables and solve, but make sure that you solve for y in order to be able to find the final inverse function. Okay, let's do one more example like this where we interchange the variables. So let's say, for example, we have our function, and our function is 4x cubed minus 5. Okay, now if we want to write its inverse, the first thing I would do is rewrite this in terms of y. So I get y equal to 4x cubed minus 5. Then I'm going to interchange my variables for the inverse. Now the minute you interchange those variables, you actually have the inverse. So at this point we will have our inverse. We're going to have x is equal to 4y cubed minus 5, but again, solve for y. So we need to solve this equation for y. In order to solve for y, we're going to add 5 to both sides. I'll get x plus 5 is equal to 4y cubed. What would we do next? We're going to divide both sides by 4. If we do that, then we have y cubed is equal to x plus 5 divided by 4. And our last step, in order to solve for y, since y is cubed, if we want to solve for y, we're going to take the cube root, and what we do to one side, we have to do to the other side. So, final thought here then is y is going to be equal to the cube root of x plus 5 divided by 4, which is actually our inverse function. So this is f inverse of x. Now the next thing you might want to do with this is to actually check and make sure you've got the correct inverse. So let's go ahead and plug some numbers in. Now remember, our original function was f of x equal to 4x cubed minus 5. Now that means if we take any number, let's just kind of verify, at least make ourselves happy that our inverse is correct. You really should work, it should work for all x's and y's, which means pick your favorite value of x. I'm going to pick 2 and plug that into your function. If we plug in 2 to our function, we're going to get 2 cubed, which is 8, times 4, which is 32, minus 5, which gives us an answer of 27. Now to verify that our inverse is correct, what we're going to do is take what? The inverse function of 27. And in the back of your mind you should be saying, oh, I hope I get 2. So what we're going to do is plug 27 into that inverse that we found, which was the cube root of x plus 5. Our x is 27 plus 5 divided by 4, which is equal to the cube root. 27 plus 5 is 32 divided by 4 is cube root. This is equal to the cube root of 8, and the cube root of 8 is 2. So that should make us pretty happy that this is actually our inverse function. Okay, now one more thought on inverses, and I do want to talk about inverses of graphs. So let's look at a function graphically and see if we can't find its inverse. Okay, so let's talk about inverses of graphs. Now what I'd like to do is have a graph, so let's draw one in here. See if we can't find its inverse. Okay, so here is a graph. Now, remember that in order to find an inverse, the x's and the y's are interchanged from our original function to get our inverse. So therefore, this graph that I've drawn has the point at -4, 0. Therefore, my inverse function, or my inverse graph, should have the point 0, -4. So that means it's going to have a point down here at 0, -4. This graph has a point at -3, +2. So where is the inverse going to have a point? It's going to have a point at 2, -3. So there's that point right there. And remember, and see there's a line segment connecting these, so therefore we're going to connect those two in that line segment. The next point that's easily noticed on this graph is the point at 0, 1. So therefore my inverse is going to have a point at 1, 0. And I also have a point here at 2, -1. So therefore my inverse is going to have a point at -1, +2. And we have this graph that, remember, we're going from here, we're going to go over, whoops, I missed. We're going to connect those through those points. And then, last but not least, I have this point right here at the point 3, 0. And so I would have what? I'm going to have a point at 0, 3. And 0, 3 is up here. So I'm going to have a point right here. So what we're going to have is this little section right here. And that will be my inverse function. So my inverse function is going to go from here to there. It's going to have this piece right in here. And then it's going to have that line segment that's up here. Now what I want you to notice about our inverse is, first thing you should notice about your inverse is that it's not a function. Okay, so this inverse is not a function. How do we know? Well, if you recall from the discussion of functions, functions had to pass the vertical line test. And this graph certainly does not pass the vertical line test. So this inverse is not a function. It does not pass the vertical line test. But it is the inverse of our graph. Just because it's not a function does not mean it's not an inverse. We can have inverses. We can also have inverses that are functions. So this does not pass the vertical line test, but it is still the inverse of the graph that we had. Okay, let's do another one. Let's do another example. And so let me get another graph here, and let's see if we can't find its inverse. Okay, so what I have here for an example is the graph of the function the square root of x plus 2 plus 1, as well as appropriate points labeled. Now what we would like to do is try to draw the inverse of this function. And again, what we're going to do is just interchange the values of x and y, or interchange the input and output values. So this graph has the point -2, 1. Our new graph, our inverse graph, will have the point 1, -2. It has the point at -1, 2. Therefore, it will have a point at 2, -1. And it has the point at 2, 3. So our new graph is going to have a point at 3, 2. And so we've got a point at 3, 2. 2, negative 1, and 1, negative 2. Those are the inverse points that match the points that we have. We're going to connect those with a smooth curve, and we will get a graph that looks like this one. And so there is our inverse function. So this was our function f of x. Here is our new function, f inverse of x. It is a function. Notice that this one is definitely a function. It would pass the vertical line test. Now let's take that function that I had up there, which was f of x equal to the square root of x plus 2 plus 1, and find its inverse like we did earlier. Now if we do that, remember what we're going to do is first rewrite this as y equals the square root of x plus 2 plus 1. And then we're going to interchange the x and y values. So we will get x equal to the square root of the quantity y plus 2 plus 1. In order to solve this, we're going to do what? We're going to subtract 1 from both sides. We're going to square both sides. So we'll get x minus 1 squared equal to the square root of y plus 2 squared. This is x minus 1 squared. If we square the square root, we just get y plus 2. And then finally, to solve for y, we're going to subtract 2 from both sides. So we'll get x minus 1 squared minus 2 equal to y, and this is our inverse function. Now, if you look at our graph up there, it doesn't actually look like x minus 1 squared minus 2. It's missing half of it. It's not a full parabola like we would expect. Now, why is that? Well, remember that square root graphs have a limited domain, and so therefore, and a limited range. So if we looked at the domain of our original function, the domain, remember, is the x values, and our domain is from negative 2 to infinity. Our range is from positive 1 to infinity. So when we go down here, remember, when we find our inverse, it has to have the domain of this function must match the range of the other, which means the domain of this function has to be from 1 to infinity, and the range will be from negative 2 to infinity. Now, having this restriction right here on our domain from 1 to negative infinity only gives us the right side of our parabola. So there is actually a restriction on the domain, and this restriction allows us to actually have a function for our inverse. So that actually allows our inverse to be a function. And sometimes that's what we do. If we really want our inverse to be a function, what we'll do is we'll restrict the domain and only get the part that is actually a function that's part of that inverse. I have one last thought for you. And when we draw an inverse of a graph and the graph itself, if you look back up at the two pictures we have above, that they are actually reflections of one another. I'm sure you've talked about reflections at some point, and these are actually reflections of each other. Normally when you talk about reflections, you reflect a graph across the, say, x-axis or across the y-axis. Inverses are not actually a reflection across an axis, but they are a reflection across the line where y is equal to x. So the two graphs should be reflections across the line y equal to x. And the reason this is because the points that don't move on our graph are the points where y is equal to x. Because if you interchange them, you get exactly the same point on the graph. Now if we go up to these examples and we draw the line where y is equal to x, and we draw a line in here, and you envision folding on that line, then what you should see is the inverse will actually lie on top of your original function and vice versa. So if you picture folding your graph, or if you actually folded your paper along that line and looked through the paper, you should see that these two graphs are simply reflections across the line. If you see my line right here, then this point reflects over to here, and this point reflects to here, that point reflects there, and the point that stays the same, the point that the two graphs have in common, is actually on the line y equal to x. And so that's a way to check to make sure your graph is correct, or it is actually a way that you could draw the graph in the first place. And this concludes our discussion about inverse functions today. Thank you.